Hi guys. Today we will back with another questions from Leetcode itself. Yeah, so let's get started. So today we have question Leetcode 2529 where it is mentioned that maximum count of positive integers and negative integers. So let's read the question first. What is given to us? Given an array of nums, an array of numbers is given to us. The array is named as nums, sorted in non-decreasing order. Sorted in non-decreasing order. So that means the elements of nums are altogether itself is sorted. Now non-decreasing means like there can be increasing means they should be monotonically increasing, and non-decreasing means they are, if there are repeated elements, then on that case we can say it is a non-decreasing in fashion, because it is not increasing every time. It is increasing, but sometimes it is going to be flat because of consecutive same elements, right? So that means the sorted nums is given to us. Now what we have to return, we have to return the maximum between the number of positive integers and number of negative integers. So now the given number, given nums array, we have to return what is the between the count of positive integers and count of negative integers. Out of them, what is the maximum among them, that we have to return. Now if on the very lame language, it is something like, in the other words, if the number of positive integers in nums is pos and the number of negative integers is neg, then return the maximum between pos and neg. So that is the number of positive integers and the number of negative integers. Now note, 0 is neither a positive and negative. That we all know. There is no point to note here. That we all know. Cool. So now understand the first test case. So on the first test case, it is given that we have 3 negative integers. Here you can see, and there are 3 positive integers. So what is the count of each? So there are 3 positive and 3 negative. The maximum count among them is 3. Now on test case 2, we have 3 negative, 4, 1. We have 3 negative and 2 positive. 3 negative, 2 positive. 0 is neither negative nor positive. So there are 2 positive integers and 3 negative integers. The maximum count among them is 3. Now here is all positive. So the number of positive integers are 4 and the number of negative integers in that case is 0. The maximum among them is 4. I think the question is pretty straightforward. So that's the reason it also like tagged as a easy. So once the brute force that you have at in your mind, like you can iterate over all the elements of the nums, and you can keep on, you can like have two variables, which is basically if the number is less than 0, then you can count the number of negative count plus 1, and if it is a positive number greater than 0, then you can increase your positive count, and at the end return the max of among positive count and negative count. So I'm not going to that brute. So brute, I think you guys are able to write it. So yeah, now it is more than easy, I have to say, but again not a hardcore medium question, but it is more than easy. You can say a easy medium type of question if you like try to solve it with the follow-ups. If you consider it with the follow-ups, then that is, I have to say, it is more than easy. Like it is a medium level of question for sure. Not actually hardcore medium, it is less than of medium, obviously. So where it is mentioned, can you solve the problem in time complexity of big of log n? So how then log n factor is going to be help us? What actually the driven factor to our thinking process? For every question, I am giving you what should be your thinking process when you are going to get a hints, when you are like getting the hints of non-decreasing, increasing, this type of trips, when there is a this type of tips, na. So your brain should be like, after solving a lots of questions, your brain should be that much capable. So like when getting you such kind of hint, you should be think about of binary search kind of approach. You should be think about binary search think of approach, because you have a monotonic sequence which is going to be monotonic increasing, monotonic decreasing. Then make your brain to think on that direction, that you should be think about a binary search of solution. So we all know the complexity of binary search is big O of log n. So that is like on uh, we know for sure. Yeah, so now understand how we can think about on binary search approach. Now let's go to our OneNote, so understand it in a better. Cool. So we are in OneNote now. Let's suppose इसका ये रोना फिर से start हो जाता है हमेशा. So we have elements are monotonic increasing. So let's suppose we have elements -2, -1, -1, 0, 0, 1, 1, 2, 3. So let's suppose we have the elements this. Now how we can fit binary search here? So we just want to know how many negative integers in our array. How we can do so? If we can point to this index, na, because we know from this index we have started. After this index, all the elements are either non-positive, non-negative, that is either 0 or maybe positive. For our case we have 0, but maybe some test cases we don't have 0. So on that case, from here itself we will start with 5, 6, 7, something like this. But for our case, let's not consider now. For our case we have 0. So we have to pinpoint which is the index from where the very last negative index has occurred. How we can do so? So every language has an inbuilt function like, so what is the last elements can be possible here. So the last elements either -1 or either -2 or either -3. So any negative elements after which there is no positive element, there is no negative elements. So after this index there should not be any negative elements. So we have to trigger our index on that point where after this there should not be any negative elements, right? Now let's go back to the code. You can get better clarity on the code itself. So we do a very standard binary search here. So yeah, so we have started one left pointer from 0 and right pointer from very end, and we have initially put our last index of negative. So that is our very last index where the negative elements just occurred. This is going to be updated by our binary search. So we have initially pointed out as -1. Now, and we have also taken one boolean variable, so which is basically stating negative appears if altogether our array negative elements altogether occur, because here you can see this array does not hold any negative elements altogether. So on that case, negative appears is going to be false. But if some array is going to be hold some negative elements, then on that case this boolean is going to be true, and our last index of negative occurs is going to be set, not -1, some index. Now do a standard binary search on this array. So we have initially, so that is the template I am following. You can take a note, take a screenshot, whatever you feel, and try to write it down to your GitHub repository for reference, so that you can use for other questions. So you initialize your left to 0, right as n-1, and you are iterating till left less than equals to r, and you have calculated your mid equals to left plus right shift by 1, so that means you are doing divided by 2. So right shift in by bit, right shift any number on bit by 1 place is going to be divided by 2. So I used bit because that is of fast, like bit manipulations operations are generally fast on computer languages. So yeah, now we have our mid. So if it is less than or equals to negative, so the index where we are standing is less than or equals to negative. So it can be -1, it can be -1, or it can be smaller than this. So if I go to the OneNote now, if I can go to the OneNote now, so our index can be stand on this index, can be stand at this index, can be stand at this index. So now our mid can be stand at here, or here. So if our mid is standing at a negative index, so what operations we have to do? We can set our, we got our negative elements for sure. So we have set our negative appears to be true, our last index of negative that we have encountered to mid, and let's suppose we got a mid at this index, right? We got our mid at this index. So that is a negative for sure. We can consider as a negative index. But is it a last index of negative occur? Is it a last index of negative occur? No, right? So on that case, we have to shift our left pointer to just after mid. So if our mid is here, so we can shift our left pointer just after mid, and we are updating our variables, because we know still now where our mid is point, that can be possibly our answer, but we don't know. We will check after shifting our left to mid +1. We will check, but that is a valid answer for sure. But we will check if we can, after going more just after our mid, can we find some answer? If not, then our answer is going to be updated by this. Our answer is updated altogether. But we will check. If our left is still less than right, if we can find some more negative elements, then that can be. So from here we are searching. So from here we are searching if we can get any negative elements after this boundary. So we have shrink our boundary. So after this, can we get any more negative elements? Till that direction? So we have shift our left to mid +1. That's exactly what I did. So here you can see that I have put my left pointer to mid +1, and if it is not, then that means we not encountered a negative elements. So let's shrink our right window to mid -1, because till after that boundary, standing at mid, if we not able to get any positive elements, so let's shrink to mid -1. Maybe before mid there can be a possible answer. So this case something like this. So if you are standing, let's suppose on this index, so let's suppose that this is your mid. your mid is standing at this. So you standing at here, you didn't get your answer. So what you can do, your right boundary, let's suppose pointing to this. So so there is no logic to keep your right to this, because if that is not a valid window, so after this there is no negative elements for sure, because our array is increasing. Our array is increasing, but not monotonically increasing. It is like non-decreasing for sure. It is not going to be decrease at points. It can be either increasing or either flat. So if that is a positive element, so to its right there should not be any chance of appearing of a negative element. So we can shrink our window to just before that. We have how we can shrink. We can move our right pointer from 3 to just before my mid. So if my mid is pointing to here, so we can shift our right pointer to mid minus. यही दिक्कत होता है इसको, ये बहुत ऊपर नीचे करते हैं. We can shrink our right pointer to mid minus 1. So exactly that we did. Now if we are able to do so, then we have everything ready. Like negative appears, this boolean is also going to be set, and our last index of negative is also going to be set. The same things, the same business we have to do for positive. Now I am not going to explain this positive part. I think if you understood the negative, you can do yourself the positive part. So I am just going to iterate over the code. If you are not understand any part, then make a comments. I will happy to help you over the comments, or if needed, then we can connect also. If on the positive part, if you have any doubt. But if you understand the negative part, it is just a copy paste of code. There is nothing, just you have to either your negative can be greater than, your less than can be greater than, or vice versa, like this way. Exactly that is. So now again we have started our left, right to 0 to n minus 1. We have created a positive appears altogether, and first index of positive, like that I already explained. Where should be our first index of positive should be point. For negative, what is the last index of negative we can point? So for positive, we can point the first index from where the positive has started appearing, because we know if we identify from where the first positive index start now, so we know after very right, after very end of that, all the numbers should be positive, because our nums is non-decreasing. Correct? So we have to find first index of positive here. So exactly the same thing. So we have figured out our mid, and if we are standing at 1, so for negative case we have to stand at minus 1, either minus 1 or less than minus 1. So for positive, either 1 or greater than 1, then we can say we encounter positive, set it true, and we can say it is a valid window for sure. And we can shrink our right to mid minus 1. Because considering, now just quickly go to the one note. So let's suppose we are standing, let's suppose we have 2, 3, 4, 5. I am considering if we have only positive indexes. So if your mid is pointing to that point, so we can say standing at this mid, you got your answer. So so now what we need, for positive, we want the very first occurrence of the positive. So from here to, we know from this right to we have all positive, but can you find any positive before that? Oh, okay, then I have to search na. If so, then move your right wherever it is pointing to your mid minus 1. So move your right to here. So then your right should be mid minus 1, and on the else case it should be mid plus 1. Your L should be mid plus 1. So exactly same things I have written here. So in that case your right should be mid minus 1, and else case your left should be mid plus 1. Now all set. Now if we have both positive appears and negative appears, then your positive count should be n. We have total n elements minus very first index where the positive occurred. This gap we have to find. So that means let's suppose we have total here as n equals to what? N equals to 4, because we have 1, 2, 3, 4 elements, and our positive occurs at index 0. So how many elements? N minus index. So n minus index is like 4 minus 0 is equivalent to 4. So we have total 4 negative elements. And similarly, see, and this case is very simple. How many negative integers? That is, if your negative index is started here, that is of index 2, and we all know our index is start from 0 base, so 0, 1, 2. That means index where your last negative index has occurred, that plus 1. That is the number of negative elements you have in your given nums. So yeah, so positive count should be n minus first index of positive occurrence, and negative should be last index of negative plus 1. Exactly what we just explained. Now your answer should be maximum of any. And if you have, so that means, so this case is going to be executed if your array has both positive and negative. But this case is going to be happen when this case is only going to be encountered if your array has only positive but no negative, because we are returning from here. So if it is both, then we are going to return from here. But if your array is only positive appears, then on that case you can return n minus first index of positive. What is the formula for positive count? We can return exactly from there. And if it is a negative appears, so that means we don't have positive appears and we don't have positive and negative both appears, then on that case it is going to execute the negative appears. And if it is negative appears, then what is our formula? Last index of negative plus 1, we are returning that only. And if there is no positive appears, no negative appears, so that means we have an array of only zeros, then on that case return 0 altogether. Yeah, no super math on that case. So yeah, now let's jump on the time complexity part. So the time complexity of this approach is for sure big O of 2 into why 2? Why 2? Explain me. If you understand this question, then you should be able to explain why 2 into log n. So the time complexity is 2 into log n because we are doing one log n for finding the very last occurrence of the negative index, negative elements, and we are doing another binary search to find the very first positive elements occurrence. So we are doing two binary search of n size array. So that's the reason it is 2 into log n. Very simple. And the space complexity, do you think, like, do you identify we are using any space altogether throughout the question? Only variables, only variables, only variables, only variables, and with that variables only we are able to calculate our answer successfully. Yeah, so the space complexity, if you are using only variables throughout your question, the space complexity is boiled down to big O of 1. So that is the most optimal time complexity and space complexity and solution for this question. And if you can see, like, our submission is like taking 0 milliseconds altogether, and here you can see like it is 100% faster than any submissions altogether happen through the Leetcode. But yeah, let's not rely on Leetcode runtime. I made a detailed video on that, why so. If you can do a multiple submissions, then your time complexity is going to be very, but yeah, that is the most optimal solutions for this question for sure. So guys, that's it for this today's question. But if you understood till this point, please do subscribe to our channel, and please turn on the notifications if we are going to upload new contents to our channel. Okay, so that's it for today. Let's meet tomorrow. Bye guys.